Welcome! Today, we're going to open up the Microbiologist's Toolkit. We're diving into a world that's literally all around us, but completely invisible. And we're going to explore the amazing equipment scientists use to finally bring it all into view.
I mean, that's the big question in microbiology, isn't it? The things you're trying to study, bacteria, viruses, all that, they are millions of times smaller than you are. You can't just, pick one up and take a look. So where do you even start?
Well, you start with a really clever toolkit. Every single piece of equipment we're about to see is designed to solve a very specific problem. First, how to keep all the unwanted invisible things out. Second, how to make the invisible things you do want grow. And finally, how to actually see them.
So our tour today is going to follow that exact workflow. First, we'll lay the foundation, which is all about absolute sterility. Then we'll get into culturing, basically giving our microbes a great home. And finally, the really exciting part, the analysis, where we get to see what we've grown.
Okay, first things first. Before you can even think about studying the one microbe you care about, you have to get rid of the trillions of other ones that are on, well, every surface. In this field, if you aren't sterile, your experiment is a failure before it's even begun. Seriously, this is non-negotiable.
So how do you get perfectly sterile? You start with this beast, the autoclave. Just think of it as a superpowered industrial-strength pressure cooker. It uses high-pressure steam to completely obliterate any and all microbial life on your tools and on the food or media that you're going to use to grow your microbes.
And the secret to its power? It's this very specific number, 121 degrees Celsius.
Why?
Because that's hot enough to kill even the toughest things out there, like bacterial endospores, which can actually survive boiling water no problem. But wait, how do you get water that hot without it just turning to steam and disappearing?
You add pressure. That's how. At 15 pounds per square inch of pressure, the boiling point of water gets pushed all the way up to exactly 121 degrees Celsius. And that right there, that perfect marriage of temperature and pressure, is the first part of the magic recipe for sterilization.
And here's the final piece of the puzzle. You hold it at that temperature and pressure for at least 15 minutes. Temperature, pressure, time. That's the combo, the 1-2-3 punch, that guarantees everything is 100% sterile.
So, putting it all together, here's how it works. You add some water, you load your stuff, and you let the first blast of steam push all the air out before you seal it tight. Then you run it at our magic numbers, 121 degrees for 15 minutes. And listen, the most important part, for safety's sake, is you wait until that pressure gauge is back at zero. Don't even think about opening that door before then.
Okay, so all your equipment is sterile. Fantastic! But the air in the lab is full of microbes, right? The second you take your sterile flask out, it's getting contaminated. That is where the biological safety cabinet comes in. It's like your own personal clean room. It's always blowing a curtain of super filtered air down, creating this sterile bubble for you to work inside. Some even have a UV light to zap the surfaces clean between uses.
And for a more classic approach, you've got this awesome duo. You use a Bunsen burner, which creates this invisible rising cone of hot, sterile air right on your lab bench. Inside that sterile cone, you take your inoculating loop, just a little wire loop, and you heat it in the flame until it glows bright red. That kills everything. Now it's sterile, and you can use it to pick up the microbes you want and move them to their new home. So simple, but so effective.
All right, our sterile foundation is solid. Now it's time to build on it. The next phase is all about culturing. We need to create the perfect little home and cook the perfect meal to get our tiny microbes to grow and multiply.
So, say hello to the incubator. If the autoclave was a pressure cooker, this thing is like a luxury resort for microbes. It's a pretty simple machine, really, but it's absolutely vital. It just holds a perfectly constant temperature, usually a nice and cozy 37 degrees Celsius, which is basically the ideal vacation temperature for a lot of bacteria to just grow like crazy.
And where are the microbes staying in this luxury resort? Well, they've got a few different room options. You've got Petri dishes, which are perfect for growing them on a solid surface called agar. It's like a nutrient-packed jello. Erlenmeyer flasks are basically swimming pools for growing them in a liquid soup or broth. And test tubes are great for smaller, more contained cultures.
But, before you can check your microbes in, you have to prepare their food. You gotta cook for them, and that's what this device is for. The hot plate and magnetic stirrer is the lab's kitchen stove. You use it to dissolve all the nutrient powders into water to make that agar or broth. The heat helps everything dissolve, and see that little magnetic pill you drop in? It spins around like crazy and stirs the whole thing for you. Pretty neat.
Now, when you're working with these tiny amounts of liquid, precision is absolutely everything. You can't just splash stuff around. That's where the micropipette comes in. This incredible tool lets a scientist pick up and move exact volumes of liquid, sometimes as small as a single microliter. And just to put that in perspective, that is 1/1,000,000th of a liter.
And the secret to using one correctly, and this is super important, is understanding the 2 stops on the plunger. You press down to the first soft stop before you put the tip in the liquid. Then you release slowly to suck it up. To get the liquid out, you push all the way down past that first stop to the second stop. That little extra push at the end creates a puff of air that makes sure every last drop gets out. It's a technique you just have to master.
Okay, we have sterilized our gear, we've cooked the microbial meals, we've given them a home, and we've let them grow. Now it's time for the big payoff. This is the moment we've been waiting for, to actually see what we've accomplished and turn it into real, usable data.
And for that, we turn to probably the most iconic piece of scientific equipment in history, the light microscope. This is our window. This is how we peek into that invisible world. It's an amazing system of lenses that takes something you could never ever see with your own eye and makes it appear hundreds, sometimes even thousands of times bigger.
And you know what? Using one is not as intimidating as it might look. There's one golden rule. Always start on the lowest power lens. That's usually the 4X. Use the big knob, the coarse focus, to get the image into view. Then once you can see something, you can switch to a higher power. But from that point on, you only touch the small fine focus knob to make it sharp. Trust me, you don't want to use the coarse focus on high power. That's how you crash the lens right through your slide.
So, seeing is believing, but science runs on data, and that means we need to count. Now, trying to count hundreds of tiny dots on a petri dish by eye, yeah, that's going to give you a headache, and you're probably going to get it wrong. That's why the colony counter is such a lifesaver. It's simple. It just gives you a backlight to see better, a magnifying glass, and a grid so you can go through and count every single colony, one by one, without losing your place.
So when you step back and look at it all, you realize none of these tools really works alone. They're all part of a system, a complete workflow. You have the autoclave giving you a clean start, the incubator giving your microbes a home, and then the microscope and colony counter letting you see and count the results. It's this beautiful process that takes something totally invisible, makes it observable, and then turns that observation into cold, hard data. And really, this basic toolkit is the foundation of so much modern discovery, from finding new antibiotics to understanding our planet's ecosystems. It really makes you stop and wonder, with these incredible instruments in our hands, what other invisible secrets are just out there waiting for us to find them?